some things about NXAI. So NXAI is a company which is focusing on highly efficient AI architecture. And based on this AI architecture, we are building AI models for industrial applications. This is what we are doing. And this Minds for Machines says it very well. When we're talking about machines or production or industrial AI, then we are talking a lot about the language of machines, and this is not words and videos, but data. And this is exactly where we launched our first models. And I can give you today a very short overview. On the one hand, what we are doing, and on the other hand, what kind of real world cases are possible with AI, which is running on edge and or even embedded. So to come to a short technical insight, and then I'm leaving this technical area. But there is Transformer, as you already said, Vlad, and Transformer has huge opportunities by being able to train parallel a huge amount of context and doing incredible things, still stunned every day what's possible. On the one hand. On the other hand, it's built on brute force technology, so you need a lot of energy, a lot of compute, and you need to scale it, and you need to have it in the cloud. And it's not very efficient to have these huge GPUs on machines running and investing more for the GPU than for the machine. So there is a limit in using these transformers, and there is also opportunities in different verticals where transformers fail. And this is where we are coming in with our technology, xLSTM. xLSTM is trying to solve the problem of brute force compute need. Transformers need quadratic compute. So if you put in context into a transformer model, then the compute is growing quadratically. If you're doing this with xLSTM models, then it's linear. And this enables a lot of very interesting segments in industrial AI for us. First, we can allocate memory to chips. And by saying that, that means we really can define models based on the existing memory on an existing chip and bring down the model to the chip for running it highly efficient and, of course, with the defined speed. And it cannot break because the linear compute on the one hand. On the other hand, of course, we are much more faster if there is huge context, much more performant. We have an open context window, and we have a state tracking also in our models. So that means when it comes to our time series model, as an example, it's not only being able to do standardized forecasting and anomaly detection and classification. One of the juices inside the model is that we have state tracking in, which gives us really a big advantage in the performance. And this is also something which is going now into the field of robots. So lots of words, but at the end, we have a very high efficient architecture, which is even par with Transformer when it comes to perception, but we are much more efficient. And that brings us to the opportunity to being able to not only going big, but also being able to go small. So, and that said, what are we doing? We launched xLSTM as an algorithm 2.5 years ago. And we started then building a first industrial AI model focused on time series, so the language of machines, Tyrex. And we launched Tyrex in July last year. Now we are even in front of launching Tyrex 2 with a lot of new functionality, multivariate and covariate data for the time series prediction and classification, anomaly detection. And we launched not only a time series model, we launched a foundational zero-shot time series model. That means even if we haven't seen any data till now, we can predict them, which is a huge thing, because if you're thinking on industrial applications, let's think on predicting pumps, then you have different liquids in these pumps, and that means different forecasts for predictive maintenance, as an example. Then you need to drain these pumps with these liquids in the environment where the pumps are running with data from the air. And this is simply not possible if you are selling 11,000 pumps a year. So what we are doing here is we're able to fine-tune this model with the pump data of different pumps, but with a lot of more data of different time series areas, which is our foundation model. And then we have one prediction and classification model for all different pumps with all different liquids, which we can continuously make better and better, and which is, of course, a huge opportunity for rolling this out and for enabling their customers, in this case, the pump customers, to have a clear prediction when they have to maintain the pumps and so on. That's what we are doing at the moment, very focused. And what I'm showing here is this can run from GPUs to PLCs, even NPUs. We are at the moment building a 5G chip together with a chip company where an NPU is running and Tyrex is on silicon. We also have already our Tyrex on Bosch Control X as an example. So we can bring it into existing infrastructure if we go to the size of the existing infrastructure that's needed. And where we are going and where we are heading with all this knowledge is in the direction of world models. This is why there is a humanoid on the right side. Tyrex as a time series model is a small world model, and world models are a very complex thing. And this is exactly where we see huge opportunity also with our knowledge and technology together with Sepp Hochreiter as one of top researchers international. And to come to the use cases, I already explained this first use case with pumps. A second use case is we have a customer who is the world market leader of creating distribution centers for food logistics. And this distribution center has the need of demand forecasts. And demand forecasting is for the producers, food producers, and on the other hand, for the retailers. So they have to know what should be produced and when will it be bought. And this is sometimes complex and sometimes not. But it's complex if you have no data because there is maybe a new product which is even new in the market. So you have no data, but you have to predict when you need more and so on. And this is exactly one of the use cases we are doing in this huge warehouses, demand forecasting, but there is also more. So there is a lot of use cases also for optimizing processes by time series model. The AI in smart factories is also something where we are working with big machine producers. We now have 3 customers with building machines. 2 of them are also world market leader in the segment. And there it's exactly the same perspective than the pump perspective. If you have different machines and you're rolling them out and you want to predict what's ever happening, or also you want to optimize the running system by having a real-time prediction of what's happening and changing the setting real-time in the machine is something we are working on. And for that, you also need to bring the model not only to the cloud, but into the factory, to the machine on edge. And this is exactly where we stand. And last not least, this robot model, where we are working now on also robotic action models. We started our new robot lab. We are so incoming 2 new humanoid robots into our office now. We have an edge lab where all these kind of chips are also running and where we can test it against our models and all other models. So we see exactly where we stand. And normally we are number 1. So if you want to have a high performant architecture and model running on existing infrastructure, also even new infrastructure, as good as possible with a great prediction, then this is what we are doing.